Hi guys, and welcome back. So today this is kind of the culmination of everything that we've been talking about over the past few days. The whole reason why we've been doing or figuring out all of these features of a quadratic function is so we can actually go in and graph them. All right, if you again need a textbook resource, this is coming from section 8.3. All right, the only thing I want to talk about before we get into the whole graphing thing is that I think I noticed some of you guys maybe either asking this or doing this on the last homework assignment. What is the y-intercept when you talk about quadratics and parabolas? I think you guys remember that the y-intercept in general is the place where the graph crosses the y-axis, and in terms of algebra, the x value of the y-intercept is always 0. All right, so if you have a quadratic function in standard form, it's this c value at the end, just that plain old number, that's your y-intercept. All right, and there is a whole reason why it is the way it is, because again, when x is 0, if you plug in 0 for this entire expression, the only thing you're going to be left with is this c value. So there's a whole proof of why it is the way it is. You could definitely ask if you need more help with understanding that. But it's really easy to pick up on just from looking at the quadratic equation, because it's just this final number, all right, is your y-intercept, all right? And that's going to help a lot when you go in and graph, all right? So we're going to figure out most of these features first, all right? Domain is all real numbers. We can just get that out of the way because that's always going to be true, all right? Y-intercept is pretty easy because, like we just said, it's from this final c value. So again, because we're talking about an intercept, I am going to look for it written as an ordered pair. So it's going to be 0, 9. The rest of this does require a little bit of work. All right, I'm just giving you a heads up now. Your homework is going to look pretty similar to what's right here, with all of these different things spelled out for you that you're going to need, as well as a little table. And hopefully, I think there will be some graph paper or some coordinate planes in there. And then you could figure out all of these features in whatever order you want. This is just what's easiest to me, because like I was just saying, vertex, axis of symmetry, and range do require a little bit of work. Axis of symmetry, I think, is easiest to do first because it's just the negative b over 2a formula. So if we use all that information here, b is negative 6. So negative 6 is positive over 2 times 1. So this is 6 over 2, which is 3. And because it is a vertical line, I will be looking for that written as the equation of a line. All right, vertical, hoi vux, x equals 3. All right. Vertex, we know this is going to be the x value of our vertex because that's what we did last time. So this is going to be 3 comma something. And to figure out what that something is, we can plug this 3 into this entire equation for x. So 3 squared minus 6 times 3 plus 9. So this is 9 minus 18 plus 9. Oh, you can't see that. 9 minus 18 is negative 9, plus 9 is 0. So the vertex is 3 comma 0. All right. Range you could also do beforehand. I think I might have mentioned that in maybe not the last video, but some video recently. I think I'll explain a little bit more after we make the graph, because I do want to talk about this table, because pretty much all of you are probably like, well, why is there a table? All right. A lot of this is really helpful. We can actually go in and plot it, but you are actually able to figure out a few extra points. All right. Because if you guys remember, well, we just talked about axis of symmetry. So in general, parabolas are always symmetric, which means they're exactly the same on one side as the other. And the vertex is straight down the middle. So pretty much every table that you're going to see on your homework is going to have 5 rows like this, all right? And because we know your vertex is in the middle, I'm going to put those appropriate or those corresponding x and y values in the 3rd row, which is in the exact middle of the table, all right? So what this allows us to do is then we're allowed to pick any two x values that are smaller than 3 and any two x values that are bigger than -3. So I'm just going to go in order. I'm going to go 3, 2, 1, and then I'm going to go 3, 4, 5. All right? Now, in order to figure out the y values, we're going to have to do a little bit of work. So we're still going to have to plug 1 in for x. So I'm going to go back down here. 1 squared minus 6 times 1 plus 9. So that's 1 minus 6 plus 9. This is -5 plus 9 is 4. So the y value that goes with 1 is 4. But here's the thing, all right? You don't have to do as much work as you think to fill out the rest of this table, okay? Because like I said, parabolas are symmetric. So what that means is, well, 1 is 2 units away from our vertex. It's going to go this way. So if something is symmetric, that means if you go 2 units in the other direction, you should be, or it should look very similar, even if you're going in the other direction. What that means is, since 1 is 2 units away from 3 this way, the x value that's 2 units away from 3 the other way should have the exact same y value, which means this should be 5, 4 as well. If you're not sure, you can always double check that by plugging 5 in as well. And I'm going to do that in the calculator just to save a little bit of time. 5 squared minus 6 times 5 plus 9. And that does get us 4. So it does work. All right. The same thing should happen with the 2 and the 4. The fancy word for that is equidistant. They're both 1 unit away from that vertex 3, 0 in either direction. So, actually I'll do the scratch work for 2. 2 squared minus 6 times 2 plus 9 is 4 minus 12 plus 9. So this is -8 plus 9 is 1. So that means this is 2, 1 and 4, 1. And that's that's the entire table. I would say fill out this entire table. I strongly encourage you to get 5 points when we're talking about quadratics. I think I might have only said 3 points minimum when we did lines and slope-intercept form, but those, excuse me, those were a lot simpler. So because quadratics, in my opinion, and I think you might agree with me, are more complex, that's why I'm asking you for more points. All right, so we can plot all of this. 1, 4, 2, 1, 3, 0, 4, 1, and 5, 4. You could absolutely draw in your vertical line for the axis of symmetry to help you out, but you don't have to. It just shows you that nice symmetry. And as always, because we have points and we're graphing a function, we do want to connect the dots, extend the line, draw the arrows, draw the arrowheads. That's not going to change. All right. For the range, we have now that it's pointing upwards. So the range is going to be y is greater than or equal to whatever the y value of the vertex is, which we found is 0. You could easily figure that out in the beginning from the equation itself because the a value is positive, which means that your picture should be pointing up, which we have it does now that we graphed it. All right. You can also find the zeros by factoring this or by doing quadratic formula. I didn't put that on in this little setup just because sometimes, as I'm sure you guys might have seen from your homework on, when was that, Monday? Not every single function is factorable, and even if you do use quadratic formula, you might end up getting some really weird numbers for the zeros that would be difficult to plot. So you could absolutely double check this. Like if you factor this and solve it, you should get 3 because that's what matches with the graph. But again, you don't have to. It's just everything all coming together. So we'll do this all over again. All right. The domain is not going to change. It's all real numbers. The y-intercept is your c value, which is 0, -5. And now we have to do some work. All right. Axis of symmetry. is negative b over 2a. So negative 8 is positive 8 over 2 times negative 2. This is 8 over negative 4, which is negative 2. So the axis of symmetry is x equals negative 2. Now we're going to take that and plug it into here everywhere we see x. So 2 times negative 2 squared minus 8 times negative 2 minus 5. Negative 2, I forgot the negative. Negative 2 squared is 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16 minus 5. So this is 8 minus 5, which is 3. You could always double check this again using the calculator. But the vertex here is going to be, what was it? Negative 2 comma 3. And if you wanted to do the range to fill in this side before you go to the table, this sign on the a value tells you that we should expect the parabola to open down. So that means y is going to be less than or equal to still whatever the y value of the vertex is, which is 3. All right. Now the table is set up exactly the same way, 5 rows, so we're going to put the vertex right in the middle. And we're going to pick 2 x values smaller than negative 2 and 2 x values bigger than negative 2. Again, technically you could pick whatever you want. I would just stick with going, like, counting down and then counting up. So in this case, I would go smaller than negative 2, and I would say negative 3 and negative 4, just continuing to count, and then negative 1 and 0. Now here's something interesting, all right? 0, we already have here. We already have the y-intercept. We were able to figure it out from the equation. So we don't actually have to do as much work as the last one. We know the y-intercept is going to be negative 5, and that means we know its symmetric counterpart. On the other side, negative 4 should also have a y value of negative 5. And again, you can check this by plugging it into your calculator. The others, we're going to have to do a little bit. We are going to have to do some work for that. So I'm going to go ahead and plug in negative 3 or negative 1. Doesn't matter. You should get the same thing. Minus 8 times negative 3 minus 5. So this is 9 times negative 2 is negative 18 plus 24 minus 5. This is 6. Why am I second guessing that? Negative 18 plus 24 is 6. Minus 5 is 1. All right. So this is negative 3 comma 1. And that means this is negative 1 comma 1. All right. So now we actually have to make the graph. We did all that work, but because the question says graph it, it's a waste unless we actually make the picture. So we just plot the point. Negative 3, 1. And it does curve down. All right. I do also want to see when you make these pictures some sort of curve. All right. It might be a little pointy here because we're not artists in here. If you could try to make this as curved as possible and make these more curved. Like I don't want to see V shapes. All right. Because a V shape is a completely different function than a U shape, which is the parabola that we're talking about. All right. So please try to make them as curved as possible. This is the exact same thing, so I'm again going to do this later. You'll see the answer to it on Google Classroom. And that's pretty much it. All right, pretty short video for a pretty short lesson, but there was a lot that went into it. And you know where to find me by now if you guys have any questions. I'm going to go answer my phone, and I'm going to talk to you guys soon.